And so this is another doubt that was sent by one of the DP2 students. So it relates to bearings. So this topic is actually common for all of the math for people, and even for extended math, right? Okay, so let's see what the question says. So this question says the boat travels. Yeah. The boat travels on 12 kilometer on a bearing of 72 and then 18 on a bearing of 140. Okay, so when we start off with it, right? So please note we mentioned point, correct? At the starting point. Now at the starting point, it's a bearing of 72. So please remember this. Whenever we are dealing with bearings, the bearings are always starting from the north and we count it in the clockwise direction. And bearings are always given as three-digit values. So this is 72 degrees. So 72 degree on this will be denoted something like this. Okay, there's no need to draw an exact figure or approximate just for the understanding purposes. It's all right. Okay, now from this point, just go to yeah, yeah. From this point, they have mentioned that it's then moving on a bearing of 141. So bearing of 141, that means here will be not 10. Okay, and then from that there should be 141. So 141 will be more than 90. So I can have an angle like this, again an approximate one. Now this is 18, so it should be a little bigger when I'm drawing. I should draw it a little bigger than the previous. Okay, so over here what we get, this is 72 degrees. This one will be 141 degrees. And then this length is 12, this length is 18. Okay, just with the information on the diagram that is done. Find the distance and the bearing of the board from its starting point. So what exactly are they asking for? They're asking for, well, let this be as it is. This, okay, this length is what they're asking for, and the angle. Design. Okay. So for this, let's figure out what all we can as of now. Okay, see, this is 141. If this is 141, then this can also be found out because the sum of them should be 180. So that is 141 plus this, let this be as angle B. So angle B would be 180. So we can find this as 39. Correct? So this is 39. Now, and this we do not know. But is it possible for us to find this angle? How much will this be? From that, we can find the green one, which is the bearing angle. Okay, everything can be done. So let's see, this is 12, that is 18. It's not a right angle triangle. So as it is not a right angle triangle, we cannot use our super theorems. Okay. So what can be done? So we'll start off with what we can find. So they have given that this is 72, correct? So that is 72. This angle could be found again. Okay, because if I label this as B, so what we get is 72 degrees plus B will be 180. So B will be 180 minus 72. So it comes to 108. So this is 108 and that is 141. So from these, even this angle can be obtained. Let's label it as C. Okay, so what we get? 108 plus 141 plus C is 360. So this is a C number. So it is 360 minus 180 plus 141. Yeah, 100. Okay, so C is equal to 100 degrees. Done. So now in this triangle, see, it is not a right angle triangle. Okay, as it is not a right angle triangle, we have two sides and an included angle. So when it is two sides and an included angle, we can use what can be done. Okay, so this will somewhere connect with either a sine rule or a cosine rule. Okay, so two sides and an included angle that follows the part for cosine rule. Okay, two sides included angle. Okay, the other condition for just for this information purposes, cosine rule, three sides are given. Okay, and then sine rule is when there are two sides non-included angle, included angle. Okay, or else when there are two angles and one side given, two angles, one side. Okay, so those are the conditions for sine rule, and this is when we apply cosine rule. So in this case, I cannot say sine rule being in place. So I will go in with cosine rule. So with cosine rule, I will get this length. Okay, this length, let's call it as d. So I'm just using the variables as they come. Okay, so how do we find d from this? D squared will be equal to 12 squared plus 18 squared minus 2 times 12 times 18 times cos of the angle between them, cos of 1. Okay, let's quickly do this. 12 squared plus 18 squared minus 2 times 12 times 18 times cos. Okay, so please make sure that your GTC is in degrees because we are dealing in degree measures as of now. 111 111 141. So what? Okay, so this comes to 622.85. We take square root of it from the left. There you go. So it comes to 24.95. I will just picture of this as well. There you go. Okay, so the GTC working just in case if you want to check it later. Different times the system take this the value comes to 24.956. Okay, okay. Whatever units they have given, please follow the same units. In this case, it's in kilometers, so that the value is in kilometers. Okay. Now that we know this is 24.56. Okay, now that we know this, then we can apply sine rule to find the unknown angle. The question mark that was there, which I will label now as. Okay, this is the angle. So for that, the sine rule will work as sine of V over 12 will be equal to this d value of 1 by 1. Sine rule, that is sine of V sine over 12 will be equal to sine of 111 over 24.956. So that gives us sine of V will be 12 times sine of 111 over 24.95. Now please note that sine E will have to be an acute angle. Okay, because whenever we are using sine inverse, there is a possibility of getting an acute angle as well. But in this case, we are only going to stick to the acute angle value because in that triangle, one is already obtuse, right? So in a triangle, it can be only one obtuse angle. So we are only going to looking for the acute angle. So 12 times sine of 111 divided by the other one. So there you go. So that's what we get. Let's take sine inverse of this. So it is 26.6734. So E will be 26.6734. Okay, done with this. Then what we get? Yeah, E is obtained, but that's not the bearing angle. Okay, because the earlier was A correct, which is 39. So bearing of the starting point of A from C would be 360 minus 39 plus 26.67. So how much is it? 360 minus 39 minus 294. This is the bearing. So we write it as 294 degrees, rounded off to three significant figures. Okay. That's how you do tedious question bearings. All the best.